Welcome to STEM Professionals. In this video, we'll discuss the questions based on Chapter 1, and the level of questions would be from easy to moderate. Now, the questions will be based on the following topic, that is the dimensional analysis. So let's start with the video. Now next 5 questions will be based on dimensional analysis, and this is the first question. And in this question they are saying that which of the following given equation are dimensionally consistent. So we have to see whether these equations are dimensionally consistent or not. So we're going to discuss the first one, which is x is equals to 1 over 2 a times t square. Now here you should know that x represents distance, a is acceleration, t is time. So now the dimension for distance, we know it is L, so we can write it as L is equals to, now 1 over 2, it has no dimension. Now a is acceleration, so dimension for acceleration is length over t square, that we discussed earlier also, multiplied with this is t square. Now t means time, so time will be, the dimension for time is t, so t square. Now here we see that this will be equal to this t square, and t square will cancel it out and we'll get L. Now here we see that the dimension of left side of the equation is equals to the right side. Therefore, we can say that the equation is dimensionally consistent. So this was the solution for the first case. Now next we can discuss the second case. So second equation we have t is equals to v over x. Now here this t is time, so dimension for time is t. V is velocity. Now the dimension for velocity we have length, that is L over time, divide with this x is distance, that means L. Dimension for distance is L. So this L and L will cancel it out and we are left with 1 over t. Now here we see that the left side of the equation have dimension t and the right side of the equation have dimension 1 over t. Therefore this equation is not dimensionally consistent. So we can write that not dimensionally consistent. So this was the solution for the second case. Now next we're going to discuss the third equation. So the third equation we have t is equals to 2x divided with a to the power 1 over 2. Now let's see its dimension now. Now time, dimension of time is t is equals to, now 2 doesn't have any dimension, so leave it. Now x is distance, so distance is length, divide with, now the dimension for a, that is acceleration, is length over t square, and this is whole to the power 1 over 2. Now this length and length will cancel it out and we'll get, this is time t square whole to the power 1 over 2, which is equals to t. Therefore we see that the dimension to the left side of the equation is equals to the dimension of the right side. Therefore this we can conclude that this equation is dimensionally consistent. So this is dimensionally consistent. So this is our next question on dimensional analysis, and this question says that which of the following quantities have the dimensions of a distance. Now we know that the dimension for distance is L. Now let us see that which of these four quantities have dimension for distance. The first one is v times t. Now v is velocity, t is time. So dimension for velocity is length over time times t. Now t is time, that is dimension is t. So that is equals to this t and t will cancel it out and we'll get L. Therefore, the dimension for the first quantity is L, which is the dimension for distance. So yes, this is correct. We can write yes, it have the dimension of a distance. Now next we can discuss the B part, which is 1 over a t square. Now here 1 over 2 doesn't have any dimension, so as it is. Now a is acceleration, so acceleration is L over t square times this is t. Now t is time, which so t square, so that is also equals to t, which has the dimension of a distance. So yes, we can write that it has a dimension of a distance. Now next we're going to discuss the C part. So C we have 2 times at. So 2 doesn't have any dimension, so as it is, acceleration is length over t square times t. Now this would be equals to L over t. Therefore, this physical quantity doesn't have a dimension of distance, so we can write no. It doesn't have the dimension of a distance. Now the final one is v over a square, and this thing I left for you. You have to give the answer in the comment box below, that whether these have a dimension of a distance or not. So this is our next question based on dimensional analysis. Now in this question they are saying that velocity is related to acceleration and distance by this expression: v square is equals to 2ax to the power p. Now we need to find the power p that makes this equation dimensionally consistent. Now we know that this equation will be dimensionally consistent when the left side, the dimensions of the left side is equals to the dimension of the right side. So this is v square. Let me write this equation. V square is equals to 2 times a times x to the power p. Now here v is velocity, a is acceleration, and x is distance. So the dimension for velocity is length over time, and this is squared, so whole square is equals to 2. Now 2 doesn't have any dimension, so we can forget it. Now a is acceleration, so length over t square, this is the dimension for acceleration, times x is length, the dimension of x, that means distance is x to the power p. Now here it will be, we can write this value as L square whole square divided with t square is equals to L. Now this L has power 1 and this L has power p, so if we combine we'll get L whole to the power 1 plus p, we can write this way, divide with t square. Now here we see that this one and this one will cancel out, so we'll get from here L square is equals to L 1 plus p. Now to make this equation consistent, the power should be same on both the side. Now here L has power 2, so it should be 2 also here. So 1 is already there, so p should be equals to 1. So if p becomes 1, then this would become L square, which is equal to the left side. Therefore we can conclude that the value of p is equals to 1, and then this equation would be dimensionally consistent. So this was the solution. So this is our next question based on dimensional analysis, and in this question we are given this equation, that is t is equals to h to the power p times under root 2 over g. Now here t is the time required for an object to fall from rest through a height h, and this g represents the acceleration due to gravity. Now we need to find the power p such that this equation becomes dimensionally consistent. Now this question is pretty similar to the last question that we discussed, and here also we're going to follow the same procedure. That is, we're going to balance the dimension of the left side of equation to the right side. So the dimension for time is t is equals to, now h is distance, so distance, the dimension for distance is L, so L to the power p under root. Now the dimension of 2, it has no dimension, so no need to write, divide with, now g is acceleration due to gravity. So acceleration due to gravity means the dimension would be L over t square. This would be the dimension for acceleration, so we can put here, this is L over t square. Now t square we can put in the numerator like this. Now it will be equals to, now t as it is, L to the power p as it is. Now this would become t, and here it would become L to the power 1 over 2. Now this is L has power p, and here it has power 1 by 2. So on simplification we can write this thing as p minus 1 over 2. Simple mathematics we have used here. So now here this t and t will cancel it out, this one and this one will cancel it out, so it will be 1 is equals to L to the power p minus 1 over 2. Now the left side of the equation has 1, so in the right side it should be 1. So if p becomes 1 over 2, this would be 1 over 2 minus 1 over 2, that is 0. Now anything power 0 would be equals to 1, therefore p should be equals to half. So we can conclude that the value or the power p should be equals to 1 over 2, such that this equation becomes dimensionally consistent. So this will be the last question based on dimensional analysis, and in this question we are given this equation, t is equals to 2 pi times under root m over k, and this t represents the time required for one complete oscillation of mass on a spring of a force constant k. So we have to find the dimension k such that this equation becomes dimensionally consistent. This equation is pretty similar to the last couple of questions that we have discussed, so I'll not going to solve the whole question. I'll going to just give the hint, and you have to find the answer, and you have to write the answer in the comment box below. So this equation we have, t is equals to 2 pi times under root m over k. Now to make it simpler, we can square both the side, so it will become t square is equals to, this would become 4 pi square, and this would be m over k. Now this can be written as k is equals to 4 pi square times m divided with, this would be t square. Now we have to find the dimension for k. So now 4 pi square doesn't have any dimension, so we can neglect this. Now if you put the dimension for m, that is mass, and if you put the dimension for t, that is time, t only, then we can find the dimension for k. And you have to find, and you have to write the answer in the comment box below. So this is all with this video, and in the coming videos we'll discuss some more questions based on chapter 1. Thank you.